Good afternoon, everyone. I'm Helen Zhang, a hydrogeologist from Ontario Ministry of the Environment, Conservation and Parks, Environmental Monitoring and Reporting Branch. In this presentation, I'll update you about the progress of groundwater-related policies, programs, and projects within the ministry during the past year. The updates will be in these four areas: the Water Quantity Management Review Project, the conclusions from the review, and the enhancement to Ontario's water managing program based on conclusions. Changes to the Permit to Take Water program at the operational level. Some initiatives undertook by the Provincial Groundwater Monitoring Network Group. The renewed Canada-Ontario Agreement on Great Lakes Water Quality and Ecosystem Health, COWA, and its funded groundwater research projects. It is well known that the ministry has completed a comprehensive water quantity management review by last year. The review had concluded that Ontario's current permitting framework is well suited to manage sustainability of individual water takings. Permit application reviews are risk-based, allowing for professional judgment and consideration of local knowledge to ensure no unacceptable impacts, including the reviews of bottled water takings. We do recognize the challenges where takings are unsustainable during low water conditions or considering growth demand. Some scenarios may benefit from considering cumulative effects rather than on an individual permit basis. Therefore, the ministry implemented changes to water management regulations and legislature to enhance Ontario's water management program, which will be elaborated in the next slide. This table summarizes the recent enhancements to Ontario's water taking program. It applies to all permitted water users, including water bottlers. The left column lists the enhancements, and the right column points out the associated amendments to guidance, regulations, and legislature. For example, establishing priorities of water use helps guide ministry decisions about how the available water will be shared among existing users. The regulation then sets out priorities of water use that the director can consider when facing situations of competing demands. Specifically, top priority will be given to environment, drinking water, and farm animal production equally. Agriculture use next, followed by industrial and commercial ones, and aesthetic use being the last priority. The area-based approach is a new tool that can be used to better understand the cumulative impacts of multiple water takings on the availability of water in areas experiencing water quantity stress. This is to replace the high-use watershed policies during the reviewing process. Other amendments include enabling the sharing of water-taking data and requiring the host municipality support for a new or increased bottled water taking application. Previously, the Permit to Take Water program was managed by 5 regional offices across the province. In April 2020, the Permit to Take Water unit was established within the Environmental Permissions Branch to centralize the provincial permitting process. On April 1, 2021, the amendments to Reg 38704 came into effect. Implementation of the amendments through operational procedures include, for example, when and how to apply area-based management. As of July 1, 2021, additional low-risk water-taking activities were allowed to register on EASR, including pumping tests, transit projects, and construction dewatering. As of November 1, 2021, issued decisions and permits were made available for public searching and viewing on Access Environment. From the ending of water bottle moratorium to the end of last year, the ministry has received 11 water bottling applications and has issued 2. And 793 permits were issued by the permit units so far. Over 5,000 PTTWs were active in the province by mid-year last year. The largest number of active permits was agriculture taking, followed by water supply, construction dewatering, commercial and industrial usage as the rest of the major water-taking sectors. Please note that this chart does not provide information about water-taking volume each sector is permitted or used. As mentioned previously, the Ministry listened to the suggestions of the practicing community and is enabling the sharing of water-taking data. Under the amended regulation, water-taking data reported by the permit holders, as well as monitoring data submitted in an application or as a condition of a permit, can now be released on request. And the Ministry is working on the new public-facing web page to consolidate and provide timely public access to existing and new data. Staff from the Environmental Monitoring and Reporting Branch and the Dorset Environmental Sciences Center have taken on an effort integrating decades of chloride data from 11 surface and groundwater monitoring programs to depicting chloride distribution patterns and trends in Ontario's waters. Chloride data in groundwater were compiled from the Provincial Groundwater Monitoring Network, PGMN wells. This figure presents the most recent chloride concentrations from 507 PGMN wells. The small labels of blue and green represent concentrations less than 120 mg per liter. The larger labels of orange and red indicate concentrations greater than 250 mg per liter, the Ontario Drinking Water Quality Aesthetic Objective, and yellow ones are concentrations in between. About 10% of the sampling locations exceeded chloride concentration of 250 mg per liter, and the median value is 20. The figure also illustrates chloride concentration trends. The upward and downward triangles represent increasing or decreasing trend respectively. Square for variable trend, circle for stable trend, and pentagons are for those do not have enough numbers of sampling results for a trend analysis. Out of all PGMN wells, 45% has shown increasing, decreasing, or variable trends, and 19% has shown an increasing trend. Data collected by a level logger in a well are water pressures. After being corrected for barometric pressure and converted into water depths, these data then need to be reviewed or adjusted by a qualified person against manually measured water levels for any areas. This last-mile professional adjustment could be tedious and time-consuming, which impacts timely reporting of water level data. Last year, we developed and tested a script to automate this correction process. This is an example of a successful autocorrection in one of the PGMN wells. The continuous measurements from a level logger shown in green have been corrected to match the manual measurements shown as yellow dots. The two dots with red outline at the bottom right of the graph were deemed outliers by the script and were excluded. You can see the correction done by the script in green provides similar results of those manually corrected in blue. Although the auto-corrected data still need to be professionally reviewed, it should provide good accuracy in most cases. Our goal is to incorporate the auto-correction into our WSGI system so that the preliminary corrected water levels can be available up to the previous day for those wells with telemetry. This will facilitate the use of real-time measurements in PGMN wells and could help identify or forecast drought and flooding conditions across the province. On May 27, 2021, Canada and Ontario renewed their commitment to restore, protect, and conserve the Great Lakes by signing the Canada-Ontario Agreement. Under Annex 9 Groundwater Quality, COA 2021 continues to focus on understanding how groundwater influences Great Lakes water quality and ecosystem health, and on identifying priority areas for action. It also includes new concepts, such as the recognition of the important role good quality groundwater plays, as well as an emphasis on understanding groundwater-surface water interactions through monitoring and modeling. Ministry staff has participated in drafting the 2022 Groundwater Science Status Report for the Great Lakes Water Quality Agreement. This is an update of the 2016 report with a summary of improved knowledge and emergent issues in the past 5 years. The ministry has supported a number of researchers studying the correlation between groundwater and the Great Lakes ecosystem health through COA funds. In addition to Groundwater Annex, the role of groundwater is also recognized by other annexes, such as nutrients, climate change impacts, wastewater and stormwater, and harmful pollutants. Some projects establish integrated climate, surface water, groundwater models to forecast groundwater levels at a watershed scale, or to simulate groundwater discharge dynamics across southern Ontario. Others estimate the loads of nutrients or pollutants, such as nitrate, phosphorus, chloride, and PFAS, that transport through the subsurface and eventually discharge into surface waters. There are also projects studying climate change impacts on the hydrologic system in northern Ontario subwatersheds. Many of these interesting projects will be presented later today by the project teams, so I won't take more of your valuable time and stop here. Thanks for listening. Any questions?